as usual on the integration of the equation is that they have the value of power. For instance, like this one, we have integral from 0 to 2 4x plus y power 3 dx. This will let it be like v. So here we will know that v equal to 4x plus y, and if this v equal to 4x plus y, let us find the dv. dv will be equal to 4x then plus the other y, because the reason why we add y, this is because we are derivating with respect to dx. That's why this y will be equal independent, and then this will be equal to dv, which is equal to 4d dx. This will be equal to constant. Then here dv will be equal to 4d dx or dv. Here let's call it dv, and then let us replace this value into the appropriate dx. Then they will be equal to integral of u. We have v, we rated v, yes, power 3 dv over 4. So this is the value of dx. dv, yes, dx. And if dv equal to 4 dx, then dx will be equal to dv over 4. And then if we know that v equal to 4x plus y, then from x, which is equal to 2, this one, then and u will be equal to 2 times 4 will be equal to 80 plus then y. And for x, from x, which is equal to 0, u will be equal to y. Then the integral from y to 8 plus y, this is our interval that we have now. Then u power 3 du power 3 du over 4. This is the value of dx as you see here. Then this will be equal to u power 4 over 4, then times 1 over 4 for this du, then with respect to 80 plus y and y. Then this will be equal to 1 over 16, then bracket 8 plus y power 4. This is the value of u minus y power 4. So here, as usual, so this will be equal to integral from 0 to 3 of 1 over 16 8 plus y power 4 minus y then power 4 with respect to dy. So let us integrate this one with respect to dy. This will be equal to 1 over 16 then 8 plus y then power 5, as usual add 1 then divide by the other degree, then minus y by adding 1 on 4, then will be equal to 5, then divide by that degree, then with respect from 0 to 3. Let us replace the value, then will be equal to 1 over 16 11 power 5 then over 5. This 11 is equal to 8 plus y, and y is equal to 3, then minus 3 power 5 over 5, and minus 8 power 5 over 5, then minus 0. Then this will be equal to 1 over 16, then times 11 power 5 minus 3, 3 power 5, then minus 80 power 5, divided by then 5 as the common denominator. So this will be equal to 11 power 5 minus 3 power 5 minus 8 power 5 divided by 16 times 5. This will be equal to, this 11 power 5 is equal to 16105 1, then minus 3 power 5 is equal to 243, then minus 8 power 5 is equal to 3276, then 8, then divide by 16 times 5 is equal to 80. So this will be equal to 128,040 divided by 80. 0 goes with this, then it will be equal to 12804 divided by 8. And this will be equal to 6402 divided by 4. And this will be equal to 3201 divided by 2. This is by 2 by 2. Therefore, the integral, we have the integral 30 integral 02 of 4x plus y power 3 with dx dy equal to 3201 over 2. So this is the value of our question, and this, let us see the last form of integrating the double integrals, and that is, the example is this one. We have the integral from 0 to 3, integral from 0 to 2, xy e power x power 2 y, then dy dx. As usual, we have this value of x squared y. Then let us use it as the equation and let it be u. Here, let us then find the integration. U will be equal to x squared then y. Let us find du. Du will be equal to x squared y then times 1, and with respect, this is with respect to y, and then du over x squared will be equal to dy. So here the integral xy e power u du over x squared. This du of x is equal to dy as usual, and this is the x y, then this is e power u, this is x equal to e power u, u is equal to x squared y, and then this will be equal to integral of x e power power u, this is y, integral of y e power u divided by x du, and u, you know that is equal to x squared y as usual. With respect to x, du will be equal to 2xy dx as usual. Then du will be equal to dx, then divided by 2xy. So here we take integral from 0 to 2, integral from 0 to 3, xy e power x squared y dx, then dy. So here integral x y e power u for du over 2xy, and this xy goes with this, then we remain that integral of e power u then du. And here when x is equal to 0, y will be equal to what? And when y is equal to 0, x, here, if x is equal to 3, as usual, from the interval 0 to 3, then y will be equal to what? Here, if x is equal to 0, if we have x is equal to 0, here we get u, which is equal to 0. If x is equal to 3, here we will get u, which is equal to x squared y. So if we have x equal to 3, replace here 3, then u will be equal to 9y. Then here the integral from 0 to 9y, this is our interval, this is 0 and this is 9y, for the e power u of du over 2. Then 1 over 2 e power u with respect from 0 to 9y. Then here 1 over 2 e times this one, u is, if it is 9y, this is equal to 9y, then minus e power 0 as usual, this one. Then this will be equal to 1 over 2 e power 9y minus 1. Therefore the integral from 0 to 2 of 1 over 2 e power 9y minus 1 with respect to dy, then 1 over 2 e power 9y over 9, this is the integration of this one, minus y, the integration of y with 1 with respect to dy is equal to y with respect from 0 to 2. Then here will be equal to 1 over 2 e power 18 over 9 minus 2, then minus e power 0 over 9, then minus 0. Then here will be equal to 1 over 2 times 1 over 9, then e power 18, then minus 1. Then this minus 1 is equal to 1 over 2 times 2, this is equal to minus 1. As usual, minus e power 0 equal to 1 over 9. Therefore, this will be equal to 1 over 18 e power 18 minus 1, then minus 1 over 18. This 1 over 9, as you see, multiplied this 1 over 2. This is in general. Then we'll be multiplying 1 over 2 will be equal to 1 over 18, and here will be equal to e power 1 over 18 divided by 18, then minus 18 divided by 18, then minus 1 over 18. Then this will be equal to e power 18 over 18 minus 18 over 18, then minus also 1 over 18 over Then this will be equal to e power 18 over 18 minus 19 over 18. This will be equal to 1 over 18 e power 18 minus 19. So the solution is equal to 1 over 18 bracket e power 18 then minus 19. Therefore our question we have, which states that integral from 0 to 3, integral from 0 to 2, x y e power x squared y dy dx will be equal to 1 over 18 e power 18 minus 19 as the solution you have. So thank you for watching this video. I wish we understand more. If you have a question, just make comment on our channel, then we reply you later, and just try to make share and like. Thank you very much. So as I said, you cancel this x, this 3 with the 3, then we remain with 2y. Here it is squared, 2yx minus y squared times x power 3 with respect from 0 to 1. And here will be equal to 2. We are going to replace where the x is with this value. This is because 1 is equal to x and here x is equal to 0. Then here it will be equal to 2y times x. This is 1. Then minus y squared times the other one power 3. Then minus, you take this 2y times x, which is equal to 0. Then minus y squared times 0 power 3. Then here will be equal to 2y minus y squared, then minus 2y times 0 is equal to 0, then this will be equal to 0. Then we remaining having 2y minus y squared. This is the value that you have, which is equal to the integral from 0 to 1 of 2y minus 3x squared then y squared with respect to dx. So this value is going to be replaced by where this equation is. Then you have integral from 0 to 2 of this function, and the value of this is equal to 2y minus y squared d. Then the other dy is this one, dy. Then let us integrate this function also. Then this will be equal to, so we are integrating with respect to y. Then 2 times y squared then over 2 minus y power 3 then over 3. So with respect from 0 to 2. So then this will be equal to 2y, as I said, squared divided by 2, then minus y power 3 then over 3 with respect from 0 to 2. Then 2 goes with this, then y squared minus y power 3 over 3 with respect from 0 to 2. Then replace this y, this 2 is called, this is the value of y, and also this is the value of y. So here replace these values and they are unknown. Then we will be equal to 2 squared then minus 2 power 3 over 3 then minus 0 squared minus 0 power 3 then over 3. So then this will be equal to 4 minus 2 times 2 is 2, it's 4, then times 2 it is 8 over 3. Then this will be equal to 0. Here we put on common denominator 3, then 3 divided by 1, this is equal to 3, then times 4 will be equal to 12, then minus 3 times divided by 3 it is equal to 1, then times 8, this will be equal to 8, this will be equal to 4 over 3. So the integral then of r 2y minus 3x squared y squared with respect to dA, where we find that r is equal to the range from xy, then 0 less than or equal to x less than or equal to 1, 0 less than or equal to y less than or equal to 2 is equal to, this is therefore is equal to, which is equal to integral from 0 to 2, integral from 0 to 1 of 2y minus 3x squared y squared dx, then dy will be equal to 4 over 3. This is our value of the equation that we have. So let us see another example, number 3. We have a question stated that integral from 0 to 1 of integral from 0 to 21 to 2y, yes, with 4 plus 2x minus y squared with respect to dx and dy. So let us integrate this equation by using the rules and the regulations of the integrating the double integrals. So let us, as I said, we are going to integrate this only with respect to dx. This integral from 0 to 2y of 4 plus 2x plus y squared with respect to dx. So here we are going to integrate this, and as you know, in the properties of the integration, if you have the chain of the equation, you integrate one by one, term by term. Then 4, we are going to integrate 4 and integrate 2x and then integrate y. So here, as you know that we consider the dx, we are going to integrate where we have the value of x. So here it will be equal to 4x, then plus 2x squared, then divided by 2 as usual, 2x. The integration of 2x is equal to 2x squared over 2x over 2, yes, plus 3, then y squared, because y is independent. So we integrate x as the dependent. So with respect from 0 to 2y. So here let us replace the value of x. This is equal to x, also is equal to x. Here will be equal to 4, then bracket 2y, then plus 2 bracket 2y, then squared over 4 over 2, yes, and plus the other y squared. This is the first equation. Then minus 4 times 0, yes, plus 2x 2, yes, 2 times 0 squared over 2, then plus y squared. So here the answer will be equal to 8y plus 4y squared, then minus 2y power 3. So here this will be equal to the solution of integration of this one. So then we replace the value we have, which is equal to 8y plus 4y squared minus 2y power 3, into the first integral that we have is equal to integral from 0 to 1 of, then we write 8y plus 4y squared then minus 2y power 3 with respect to dy. So here, let us work out this one. This will be equal to, integrate this. This will be equal to 8y squared then over 2 plus 4y power 3 then over 3 then minus 2y then power 4 then over 4. Then from 0 to 1. And this will be equal to, replace 1 by 2. Yes, will be equal to 1 by 2 will be equal to 4. Then by 2, 1 by 2, 2. Then we remaining, the question stated by 4y squared plus 4y power 3 then over 4 over 3, yes, minus y power 4 over 2 with respect from 0 to 1. Here will be 4. Yes, I want to replace these values because we know that this is equal to y and this is equal to y. And then 4 times 1 squared then plus 4 times 1 power 3 over 3 then minus 1 power 4 over 2. Then minus, we have 4 times 0 squared, 4 times 0 squared plus 4 times 0 power 3 then minus 0 times power 4 then over 2. This will be equal to 0. And then remaining is 4 plus 4 over 3 then minus 1 over 2. Then minus the other 0. Here it will be equal to, let us put common denominator, the LCM will be equal to 6, then will be equal to 24 plus 8 minus 3, which will be equal to 29 over 6. So therefore, the integral R 2y minus 3x squared y squared is dA, where R equal to xy from 0 to x also to 1, and from 0 less than or equal to y less than or equal to 2 will be equal to 29 over 6. This is our solution. Let us see one last example, and is number 4. This will be equal to integral R 4x plus y power 3 dA, and R is equal to, we have the interval which is equal to this one, and interval 0, 3. So we let that this one will be equal to A, B, and this will be equal to C, D. Then we do the same as the first example. Then we will be equal to integral from 0 to 3, integral from 0 to 2. This is the interval which is equal to this one, and this interval will be equal to this one. And for x plus y power 3 dx d dy. Let us integrate this one, and then will be equal to integral from 0 to 2 4x plus y, then bracket power 3 dx. So here, welcome to the Excited Education channel, the YouTube channel, which brings you about mathematics and biology. Now we are going to discuss about mathematics on the point of double integrations. Now I would like to encourage each and everybody who is watching this video first to make subscribe, then after share the video and make the comments, even like in this module of mathematics brought by Jaime Chris. Just welcome. Let us go ahead with the module. So on the first video we have seen about the first degree of integration, but now we are going to use the double integrand of the integration. So this is the integral to this is to integrate the twice of the integrand that you have. So let us use an example to work out the integrand in the double series, or the what we call the double integration. Let us use this example. We have the integral from 0 to 2 with integral of from 1 to 3 x y squared dy to the dx. So here you have to think that you know that in this equation we have two equations of integration. We have this one, and even integration with this integrand with respect to dx, and with that one with respect to dy. So what you have to do, you have to think about to work out the first equation. Well, let us start with this one with respect to dy. Here we'll go through with this one, integral of from 1 to 3 of x dy squared, then integral from 1 to 3 x y squared dy. Now we are going to integrate this. After the result we get from this integration, then we will use it to integrate this one. Here we know that with respect to dy we are going to integrate this y. So you know that if you are integrating y, you add 1 on the power or on the degree of the unknown and divide by the additional power of that unknown. Then this will be equal to x y 2 plus 1, then will be equal to 3, then divided by that power, this is equal to 3, or with respect from 1 to 3. So to get the result of this, you will take the x over 3 then times this y. You will take y minus, by replacing 1, then minus this value also when you will place 3. Here it will be equal to 3 power 3, then minus 1 power 3. This will be equal to x over 3. This is b9 minus 1. Here it will be equal to 10x over 3. This is the first value we see on that integral equation, this one. Then we are going to replace this value into this one and then integrate with the second integral. So here you will be equal to you will take, here it is 27, not 9, 27, and here the answer will be 26. Then let us go ahead with this one. Then we'll be equal to integral or from 0 to 2 of that value of this integral. This is 26x then over 3 with respect to dx. Here the answer will be equal to, here we have the coefficient as the coefficients did not get get its integral. Then the integral with respect to x of x will be equal to 26 over 3 x squared, then divided by 2 with respect to from 0 to 2. This will be equal to 26 over 6. Then here will be equal to 2 power 2, then minus 0 power 2. Here will be equal to 26 over 6 times 4. Then the answer will be equal to 4 times 6 will be equal to 24, and recurring 2, then 4 times 2 will be equal to 8, plus 2 will be equal to 10, then over 6. So therefore the integral of 2 from also integral 1 to 3 of x y squared dy with dx will be equal to 104 over 6. This is our solution of the question that we have. This is how we work out what we call the second or the double integration. So let us see the example number 2. We have the integral from 0 to 2, integral let us use this example. If we have the equation written like this, double integral of r 2y minus 3x squared y squared, then dA, and we have that r will be equal to x y with respect 0 less than or equal to x less than or equal to 1, and 0 less than or equal to y, and y less than or equal to 2. This is the interval that we have. We are going to work out this equation with respect to this interval. Here it means that the integral, if it is 0 less than or equal to x less than or equal to 1, it means that it is from 0 to 1, and integral, if it is 0 less than y less than 2, simply means it's from 0 to 2 of the function that we have 2y minus 3x squared y squared with respect to dA. dA is equal to dy then dx. So this will be equal to dy then dx. So here we do the same as the first example, where we take the integral of from 0 to 2, integral from 0 to 1, 2y minus 3x squared y squared dx dy. Then we are going to work out this one as first equation, and then this will be equal to integral from 0 to 1, 2y minus 3x squared y squared with dx. And here it will be, let us integrate this equation. This will be equal to 2y x minus 3y plus 3, then x x power 3 over 3. As you know that we are integrating with respect to dx, then that's why we integrate this value of x. Then with respect from 0 to 1,